Hello everyone. So welcome to this session. So in this session we will going to discuss about the changing into polar coordinates. So here let us begin with introduction. Double integrals in Cartesian coordinates can be challenging. Transformation into polar coordinates simplifies the process and make calculation more manageable. And this presentation will explore the benefits and techniques of transforming double integrals into polar coordinates. Definition of a double integrals. Double integrals represent the volume under a surface over a region in the plane. In Cartesian coordinates, the limits of integrated integration are defined by rectangular boundaries. The process can become complex for certain shapes. Advantage of polar coordinates. Transforming into polar coordinates allows for simpler integration limits, especially for circular or sector regions. The process also simplifies the calculation of Jacobian determinant. Let us learn about the basic concepts of changing polar coordinates. The transformation involves replacing x and y with r and theta using the equation x r cos theta and y r sin theta. The limits of integration are also transformed accordingly. So Jacobian determinant in polar coordinates. The Jacobian determinant for the polar coordinate transformation is calculated as the absolute value of the determinant of the matrix of partial derivatives. And this determinant simplifies to just r. Double integration in polar coordinates. Double integrals in polar coordinates are great help when we want to evaluate iterated integrals, particularly double integrals of expression that involve circular regions. Being comfortable working with polar coordinates in general is important if we want to explore a wide range of topics in math and applied science, and this is why we must know how to integrate expressions by converting them into polar coordinates. Application in engineering. The use of polar coordinates in double integrals is prevalent in engineering applications, especially in the problems involving circular or symmetric regions. The simplification of calculation is highly beneficial. So what are the limitation and consideration with polar coordinates? While we're dealing with polar coordinates, it offers immense advantages. Certain regions may still be more complex to express in polar form. Understanding the nature of the region and choosing the appropriate coordinate system is crucial. So calculation techniques. So under we have various techniques such as completing the square and symmetry exploitation can simplify the process of setting up and evaluating double integrals in polar coordinates. And these techniques are essential for efficient calculations. And if you want to talk about numerical methods, in this we have Monte Carlo integration and adaptive quadrature can be applied to evaluate double integrals in polar coordinates for regions with complex boundaries or irregular shapes. Real world examples. So, real world example like center of mass. and center of a circular plate, or determining electric flux through a circle region could be calculated using the polar coordinates, and it could be demonstrated the practical application of double integrals in polar coordinates. In conclusion, transformation into polar coordinates simplifies the calculation of the double integrals, especially for circular or symmetric regions. Understanding the advantages, techniques, and limitation of polar coordinates is essential for efficient and accurate computation. So here is an example for changing of a given equation into polar coordinates. Here we have integral of a to 0 and integral of 0 to root of a square minus x square into root of x square plus y square dy dx. First we have to take x is equal to r cos theta, y is equal to r sin theta. So we have an equation for this. We have x square plus y square is equal to r square. So x square plus y square. So here the square will come left side. So it's going to be act as a root for this. Whenever we are doing integrals, we should have dx dy, that is r dr d theta. So here the x square plus y square is equal to a square, that will represent the circular. It's a circular equation. So r varies from 0 to a and theta varies from 0 to pi. So on integrating, while taking, by replacing the x by 0 to a, 0 to pi, and replacing y and this thing with 0 to a, we obtain I is equal to integral of theta is equal to 0 pi, that is x cube by 3 whole to the power of a 0 d theta is equal to integral of 0 to pi, that is after integrating we obtain a cube by 3, we take it out of the integration, so 0 to pi it will become. So finally we have obtained pi a cube by 3. Thank you.